Hello, I'm Hallam-Baker with Komodo Group, and today I want to talk about a project we've been working on in the lab for the past couple of years called the mathematical mesh. And what the mathematical mesh is about is making computers easier to use and making computers secure, in that we're using cryptography and security to make the computer easier to use. There's a demonstration podcast that goes along with this presentation in which I show configuring secure email for Alice here. So in this podcast I want to explain what that demonstration was about and why it's designed the way it is. So first off, why worry about internet security at all? Well, do we really need to talk about that? Well, actually we do, because there is a crisis in internet security, but it's probably a lot worse than the crisis that you're aware of. In that the internet's not just about Facebook and Twitter and entertainment and e-commerce and banking. The internet has become completely enmeshed with modern society. Every time you buy something from a supermarket, that has got on the shelves because it's come on a truck that has been monitored through the internet. Every parcel that is shipped from A to B is tracked through the internet. The internet is embedded in the electricity distribution system, the water, the gas, all the infrastructures that modern society depends upon are now connected up to the internet. So it's not just the internet that follows us from cradle to grave, it's internet insecurity. This is a webcam and you can buy them online, and many people get them and they put them in their offices and their factories and their homes. And there's a search engine that allows you to search for webcams with particular types of picture. So if you're into sleeping babies, you can select webcams with sleeping babies. How creepy is that? I think pretty creepy. And it's not just entertainment, it's the critical infrastructure, because modern society depends upon the internet for its existence. It's only been around for 20 years, but we're now depending upon it. Back in 1965, there was a power cut that affected the whole northeastern seaboard of the United States for several days. New York City lost power. There were riots because without the power, no television. People get bored, people get angry, people go out, people demonstrate, police overreact. Modern civilization is a much more fragile thing than people imagine. And if we don't have the internet there, if it's not secure, the internet can be used as a vector to bring down the power system, bring down the water system, bring down the transport system. And unfortunately, those infrastructures, they all use the same process control protocols that haven't changed in the past 30 years since I used them when I was an intern at ICI. It's not just industry that has problems here. This is the headquarters of the National Security Agency, and if you're watching this podcast, it's a fair bet that you're aware of the Snowden papers and what they revealed about what was going on in this building. Well, the Snowden papers tell us about that, and that has a lot to do with why we're building the mesh now. But the Snowden papers tell about something else. Because here you have the agency that is tasked with keeping the United States secure, tasked with securing its vital digital assets, and it can't even keep control of its own secrets. If they can't make cryptography easy enough for people to use that they will use it themselves, we have a problem. we have a big security problem. So internet insecurity cuts across a whole series of people, audiences. And so this series of podcasts has to do the same. First, I have to reach out to and convince my peers, my fellow designers of information security protocols, because I've been in this game 20 years and I wouldn't use an information security application unless they were confident it worked, unless they had reviewed it and were pretty sure that it was right. And you shouldn't either. Don't trust me. Don't even trust my code. Trust review, trust open review by experts in the field. I mean, like, after all, there is an alien robot sitting behind me with a blaster pointed at me. So I need to reach out to that audience. I also need to reach out to the audience of internet developers who write the applications and administrators who keep the systems running, because without them, nothing can happen, because the users depend upon those people making the mesh available to them. And finally, I need to reach out to everybody who uses the internet. The internet is for everyone. It wasn't created just for a technical elite any more than the web was designed just for use by nuclear physicists. No, it was invented from the start to be a mass medium of communication. And if you're going to change the internet, you need to reach out to all the internet users and explain what you're doing. This particular podcast is targeted at all three audiences. Later on, I may be making podcasts that are assuming a certain familiarity with cryptography and cryptographic protocols that are targeted at information security specialists. And I'll also be making podcasts that are introductory material for people who are not familiar with cryptography but want to learn. So later on, different podcasts may be targeted at one audience or another, or may have suggestions for what you might want to watch first. So we see the rationale for why we're building the mesh, but let's ask another question. Why did the internet get so insecure in the first place? And here opinions differ. You see, if you talk to my colleagues, what a lot of them will say is that the reason the internet is insecure is you. You don't want security, they say, because you don't want to put up with the inconvenience of having to think about security when you're trying to do your work. Which was why explaining this using Scott Adams' version of Dilbert, because she's an engineer and she actually knows about cryptography. Users shouldn't need to be thinking about security. When I'm using the stove downstairs, I don't have a button that I have to press saying, "Don't burn down the house." That would be a pretty rotten stove. You wouldn't want to use a stove like that. The stove is secure by default. And that's what we need the internet to be. The type of internet security that the users don't want is this type of security. Mindlessly complex, not explaining a damn thing what it's trying to do, not explaining how it's doing it, or why. There's an old security adage in Britain, security must make sense. Modern internet security applications just don't make sense to the users. Don't expect them to use them until they make sense. They're also pretty rotten to use. I spent 30 minutes trying to configure a well-known email application to use S-MIME security. 30 minutes, and I know what I'm doing. There was a 12-step series of instructions for how to do it. 12 steps, 5 different programs involved. The mesh design goals changed over time. At first, our objective was simply to make cryptography easy to use. And that really didn't work, because what is easy tends to mean a very different thing to a technical expert than an ordinary person. And that 12-step instruction set that I mentioned earlier Somebody thought that was easy to do because each step was easy and explained. Oh, yeah. So pretty early on we realised that if we're going to get people using cryptography, instead of trying to work out what users will tolerate, we've got to make the cryptography so easy to use that the users don't need to think about it. They don't need to be aware of it happening. So a cryptographically secure application shouldn't require any more effort or thinking, or to be used in a different way to a non-secure one. And I demonstrated a system like that called prison-proof email at the Hope Conference in New York 18 months ago. The mesh is an evolution of that system, because what we realized was that even that wasn't going to be enough. If we're going to make the internet secure, it's not enough to simply make the internet secure by default. We've got to give people a reason to use the secured version of the internet. So we've got to make the computer easier to use and also make it secure. So this is flipping the question around. Instead of asking, how do we do cryptography and make it easy? We're looking at saying, how do we apply cryptography to make the computer easier to use? We came up with a series of design principles I'll explain over time, but the first and the most important was explanations, not instructions. If you're giving the user 12 steps instructions, you're doing it wrong. In fact, you shouldn't need to give the user instructions at all. Instructions are for computers. They're good at following instructions. Humans aren't, and they shouldn't try to be. But humans do need to be told what they're doing and why they're doing it and how it is making them secure. Security must make sense. So give the instructions to the computer, don't make the user follow them. The demonstration part of the presentation, what we're doing there is to show that using the mesh, it is possible to configure a cryptographic application without the user having to think about doing it. One-time configuration, and after that, all the maintenance of the crypto is going to be done for Alice. She doesn't need to think about it. Because the thing is, most internet applications already have cryptographic capabilities built in. These are cryptographic ruby slippers. If we go to Wizard of Oz, you already have email security built in to email client, and you probably don't know about it. And the reason for that has to do with the way that email encryption evolved. We had many false starts. In fact, we had 5 different standards attempts. 2 of those have survived, and the fact that 2 survived is an ongoing problem because it's kind of like a VHS versus Betamax situation. Neither camp wants to give ground to the other, and they've both lost sight of the fact that the original goal was to give internet users tools to encrypt their mail. So the older of the 2 that is commonly used today is OpenPGP. It was published as an IETF standard in 1998. It offers strong end-to-end security, and it has a user base of between 1 and 2 million. Most of those are system administrators or programmers, people who act as evangelists for technology, and so OpenPGP has mindshare. What it doesn't have is deployment. There isn't a platform that comes with OpenPGP embedded as default, which means you have to go and think about it and add it to your email client. And now you're managing 2 programs, not just one, and they have to talk to each other. And that ends up as a usability challenge. The second email encryption program, protocol, is S-MIME, also an IETF standard. It was published a year after PGP, and it also offers strong end-to-end security. In fact, it's so strong that you can use it for in US government for communicating documents up to top secret. It does have an active user base, about the same size of OpenPGP, possibly a bit larger depending upon how you measure it. And that's usually people who are working in government or working in enterprises that work with the government. So it is used. And it does come in your Windows, in your Mac, even on Linux. It comes in the default email applications by default because it's a checkbox item. If you want to sell stuff to government, you have to meet that criteria. The only problem is that there's a difference between the people who demand S/MIME security and the people who have to use it every day. And so it has to be present, but the implementation doesn't have to be particularly good. It's 12 steps in instructions on how to do simple configuration. So what was going on in the demonstration part was we showed, first of all, we created a user profile for Alice. And this is going to be a cryptographic profile that is going to be the same for Alice's entire life. She can add applications to it, she can add devices to it, she can take them away. But this is going to be a cryptographic context that remains with Alice her whole life, so that that fingerprint I showed you in the demonstration, that's never going to change. And then the next thing we did was we created a profile that's just for email security and attached it to the long-term persistent profile. And this is a profile that deals with just email security, and that can change over time. And so we can reset our email encryption profile once a month, once a week, once a day if we like. And because that's all done automatically, Alice doesn't need to think about it. Once we took that profile, first thing we did was we encrypted it, and then we sent it out into the mesh, which is basically just a fancy name for the cloud, which is just a fancy name for we don't care. When people are talking about cloud computing, the whole point about cloud computing is there's a whole series of things you need to do to run a computer. You need to buy a machine, you need to put it in a rack, you need to give it internet connectivity, you have to cool it, you have to give it power, you have to dust it every so often, you have to back it up. All those things that have to be done, well, let somebody else think about it. They're just going to be done by somebody. The machine is just going to be in the cloud. Now, the mesh is a very special type of cloud. It's an untrusted cloud service. What do I mean by that? What I mean is we don't care where the data is stored, because whoever is storing it, whoever is looking at the communication channels to and from the user in the mesh, doesn't matter. They can look at every bit and it's not going to give them any information, because we don't depend upon access control for our security. We rely on cryptography. So the evil robot in the corner, we can use his cloud, we can use his mesh. Doesn't matter, because we're not relying on the trustworthiness of a third party for the security here. The mesh is not trusted, only the cryptography is. And then when we connected to a second machine, what we did was we used strong cryptography to establish a communication channel between the mesh profile manager and the device that we were connecting, so that we could initialize a cryptographic context and then securely move the profile from the mesh into Alice's device without compromise. This is what we call end-to-end security, because we don't care about what happens in the middle of the network. All the security is controlled at the endpoints. It's always been regarded as the gold standard of security. Now, in later podcasts, I'll give you reasons why maybe that's a bit of a naive view. But the point is that for this particular application, end-to-end is exactly what we want. And so we're using the mesh, which is an end-to-end key management system, to establish keys for end-to-end secure mail. But it doesn't need to be limited to just mail. We can use it to secure website passwords. Are you fed up with having to remember passwords for every stupid website that you go to that wants you to create an account? I certainly am. We can use it for SSH, which is a tool that programmers and system admins use to log into other machines. You can use it, you can configure it by hand, but doing that properly and doing it securely is actually quite a bit of time and effort. And most of the people that I know either don't do it properly or they've written a set of scripts to do it. Well, using the mesh is going to be better than a set of scripts, because this is a set of scripts that we can vet, we can audit and check for cryptographic integrity. And we can use it for virtual private networks, and then we can also use it, we've lost our Internet of Things. We can also use it to secure our Internet of Things. When we're using these $5 Raspberry Pi Zeros, we can use the mesh to establish a cryptographic context between Alice's long-term profile and the computer in a dishwasher, her computer in her clothes washer, in her thermostats, in her light switches, in her garage door opener, in her car. All the things that Alice has that are going to have computers in and going to need security, she can now have strong cryptographic security without having to think about it. So that's the mesh, and hopefully if you're convinced and you think that you'd like to make it happen, well, what's it going to take? If the mesh is going to happen, it's got to be supported in the platform. It has to be something that comes in Windows, comes in OS X, comes in iOS, comes in Android by default. And for that to happen, we need to get a large number of players in the industry involved. We've got to get the Microsofts, the Googles, the Apples, Facebook. We've got to get everybody involved in making the internet secure. I can't make this happen on my own. To make this happen and to make it happen right, the mesh has to be built into the platform. I can provide you with a program that sits by the side and manipulates cryptographic context, but it's much better if all those features are built into the programs themselves. And for that to happen, I need to show that there's a groundswell of support for this idea. So I need you, and in particular, I need you to like my video so that it gets seen and so that other people can look at it and see. And the more likes we get, the more people we get watching this video, the more likely it is I can convince Microsoft and Google and all the rest who needed to make it happen that yes, people do want security. They don't want perverts looking at webcams of their babies sleeping. So that's the mesh. And so far I've been talking about cryptography. I've been telling you that cryptography is going to make your digital life secure. What I've not done yet is proved it. And so, maybe Phil's wrong. Maybe cryptographic security is not the best security you want. Maybe you want homeopathic security instead. Well, what I'm going to do then is I'm going to give a short course on cryptography, and in particular I'm going to show you why cryptography, strong cryptography, is such a powerful tool. And to do that, there's a story. In fact, one of the older stories that we have comes from a poet who lived about 600 Common Era and lived in Iran. And he told us a story about this game, chess, that really shows the heart of why cryptography is such a powerful tool. And so that's what I'm going to be starting on in the next podcast, which is a course on cryptography. So thank you for watching, and please watch my next podcast, and please like this one. Thank you very much.